Today we're going to talk about Gauss-Jordan elimination. So, Gauss-Jordan elimination is a method for matrices. We can use them to firstly find the inverse of a matrix. Secondly, we can use them to solve a system of linear equations. So solve equations. So let's just try out finding inverses first. So let's just say we want to find the inverse of matrix A, which is a 2 by 2 matrix. -3, 5, 6, 8. Okay, so we want the inverse. And what can we do? The first thing we actually need to do is to form an augmented matrix. So this is how you spell augmented matrix. So an augmented matrix is essentially two matrices slammed together. On the left hand side, we should write -3, 5, 6, 8, which is our original matrix A. On the right hand side of our augmented matrix over here, we need to write the identity matrix, which is 1, 0, 0, 1. Our goal is to transform the left side through certain operations into the identity matrix. So the resulting augmented matrix would be like this. And then on the right hand side, we have something else, right? This something else will form our inverse. So what can we actually do to the augmented matrix so that we can transform it into a different augmented matrix? Several things we can do here. First thing, we can multiply. So we can multiply a row by a scalar. Or I should say by a non-zero scalar. Because if you multiply the entire row by 0, so there's 2 rows, right? Let's say we multiply the first row by 0. It's just going to give you 0, 0, 0, 0. So that's not really helpful, is it? The second thing to do is we can add or subtract a multiple. We can add or subtract multiples of rows from one another. So let me just write that down, from one another. So let's just go ahead then. The first step we're going to do is, firstly, we're going to look at the two matrices, the left hand side and the right hand side one. How do we make sure that this becomes 0 and this becomes 1? So we want to transform the first row first of all. Well, firstly, something we can do is so how do we turn this into 0? That looks a bit easier. So we turn this into 0. We want to essentially, so we can't multiply the first row by 0 because it says non-zero scalar over here. So if we multiply this by 0, the entire row is 0. So that's not really helpful. So the only option is to add or subtract multiples of row 2 from row 1. And then we can cancel 5 out and make sure that this is 0. So this is row 1. We'll represent it with R1 and R2. That's row 2. So our first step of working out would be we want to replace row 1 with, so we want to replace row 2 with 5 over 8 row 2. So let me explain this. Essentially, we want something here such that when we add or subtract row 1 from row 2, we can, so when we add or subtract 2 rows, we need to add the corresponding elements or subtract the corresponding elements from one another. For example, if we were to add 2 rows right now, we would have 5 plus 8, which gives us 13. So essentially, we want this part to be 5. So then we can subtract row 2 from row 1 and we can get 0 in the new row. So if this was 5, 5 minus 5 would be 0, right? So we want 8 to become 5. How do we do that? We can just multiply 8 by 5 over 8. So this just basically says that new row 2 is replaced by 5 over 8 times the original row 2. So what does this give us? Firstly, row 1 is kept the same because we didn't do anything to it. So we'll just copy that over. Now row 2 is different. So we have to multiply 5 over 8 by every element in that row. 5 over 8 times 6, what is that? So that gives 15 over 4. 8 times 5 over 8 is 5. 0 times 5 over 8 is 0. 1 times 5 over 8 is 5 over 8. So that's our new augmented matrix. The second step here, so that's step number 1. Step number 2 is that we want to subtract row 2 from row 1. And so this means that we want to replace row 1 with the original row 1 minus the original row 2. So row 1 is negative 3 minus 15 over 4, which is negative 27 over 4. And then the second element gives 5 minus 5, which is 0. Third element is 1 minus 0, which is 1. And then fourth is 0 minus 5 over 8, which is negative 5 over 8. So just simple subtraction over here. And row 2 is just the same, because we didn't do anything to row 2. Okay, so what's our third step then? Our third step is we want to turn this into 1. Because if this is 1, then we already have our first row, which is 1, 0, something, something. So we're closer to our identity matrix. So what can we do? We will just multiply this by its reciprocal, which is negative 4 over 27. So we multiply the entire row by this non-zero scalar. So we replace row 1 with the original row 1 times negative 4 over 27. So what's the result? The resulting row 1 would be, so the first element would be 1. The second element would be still 0. The third element would be negative 4 over 27. The fourth element, that's a bit harder to calculate, but we can do that. That's just negative 5 over 8 times negative 4 over 27. Now the negatives cancel out, so let's just ignore those. The 4 and 8 gives 2. So that's just 5 over 54. And then row 2 stays the same because we didn't do anything to row 2. Okay, so right now we already have our first row in place because we want the left hand side to be an identity matrix, and we already have our first two elements, which are 1, 0. So we're halfway there. Now we want to transform row 2. So firstly we want to get rid of this. We want 15 over 4 to become 0 because the row 2 of the identity matrix is 0, 1, right? So how do we let this become 0? Essentially what we need to do is row 2, so we replace row 2 by row 2 minus 15 over 4 times row 1. So 15 over 4 times row 1 gives 15 over 4, 0, and 2 other elements. So we can do that step by step. And then row 2, the original row 2, we subtract 15 over 4 times row 1 from the original row 2. So row 1 stays the same because we aren't replacing row 1 with anything, we're replacing row 2. So that's that. Row 2, we want row 2 minus 15 over 4 times row 1. So the first element of row 2 is 15 over 4. We subtract that from 15 over 4 times this element, which is just 15 over 4. That's just 0. Simple. Then we have 5. 5 minus 0 times 15 over 4, which is just 0. So that's 5. And then 0 minus 15 over 4 times this. Negative 4 over 27. So the 4's cancel out. The 3's, so we can cancel out 3 here. That's 5 over 9. So this gives us 0 minus negative 5 over 9, which is just positive 5 over 9. Okay, and then we have 5 over 8 minus 15 over 4 times 5 over 54. So this just gives us, so we can cancel out the 3, which is just 5, and then this gives 18. So this essentially is 5 over 8 minus 5 times 5, which is 25, over 4 times 18, which is 72. So we want to turn 8, we want to have common denominators. So we want to multiply the top and bottom of this by 9. So 5 times 9 is 45, minus 25. 8 times 9 is 72. So the result is 20 over 72, which is essentially just 5 over 72 divided by 4, which is 18. So we have 5 over 18. Now we want this to be 1. So what can we, and we're done. So what can we do? Something we can do is just divide both. So we can just divide row 2 by 5, or we can multiply it by 1 over 5. So row 2 is replaced by 1 over 5 times the original row 2. So row 1 stays the same. So let's just copy that over. It's 1, 0, negative 4 over 27, and then 5 over 54. And then row 2 is multiplied by 1 over 5. 0 times 1 over 5 is 0. 5 times 1 over 5 is 1. 5 over 9 times 1 over 5 is 1 over 9. 5 over 18 times 1 over 5 is 1 over 18. So we have our identity matrix on the left, so we've reached our goal. The right-hand side is just the inverse of A. So the inverse of A is just negative 4 over 27 and 5 over 54, 1 over 9, and 1 over 18. Okay, so that's our inverse then. Pretty simple. I mean, I guess it's not really simple. I mean, it's only 5 steps. However, it seems to have taken us a long time. But that's because it's our first time doing this. As you do a lot of problems, you can Google up Gauss-Jordan elimination practice problems, matrices inverse, or something like that. As you do a lot of problems, this will get really, really fast. It'll take you like only 4 to 5 minutes. So that's gonna be, and then it might just take you 2 to 3 minutes in the future if you practice a lot. So thanks for watching. Next time we'll use Gauss-Jordan elimination to figure out even harder things, like let's say solutions to a system of linear equations with 2 variables, or maybe even the inverse of a 3 by 3 matrix, which we haven't learned before. So thanks for watching. Bye.